Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Now let's start. Welcome, everyone. Today, we are diving into the world of blockchain technologies, a revolutionary concept reshaping industries globally. Our focus will be on three main aspects: the structure of a block, how transactions are managed, and how distributed consensus is achieved. These are the fundamental pillars of blockchain technology. Blockchain is much more than just a technical buzzword. It's a secure, transparent, and decentralized way to record and manage data. By the end of this session, you'll understand how it works and why it matters. Slide 2. What is a block in a blockchain? A block is essentially the building block of a blockchain. Think of it as a container that holds specific types of data. Let's break this down. 1. Header. This part includes metadata such as the block number, a timestamp, and the hash of the previous block. The hash acts as a unique digital fingerprint, ensuring that no two blocks can be identical. 2. Data. The actual content of the block, which usually consists of transactions or records. 3. Hash. The hash secures the block. If even a tiny bit of data is altered, the hash changes, alerting everyone to tampering. Analogy. Imagine a block as a page in a notebook. Each page records some data and is uniquely numbered. It also references the previous page, creating a chronological and unbreakable link. Slide 3. Block creation process. How are these blocks created? 1. Transaction gathering. The blockchain system collects multiple transactions from users. 2. Hash calculation. Each block is assigned a unique hash, generated using cryptographic algorithms. This ensures the block's integrity. 3. Linking. Every block links to its predecessor by including the previous block's hash in its header. 4. Validation. Before a block becomes a permanent part of the chain, nodes participants validate it, ensuring no fraudulent transactions are included. This process ensures that every block in the chain is secure and trustworthy. It's like building a secure vault for data that cannot be tampered with. Slide 4. Transactions in blockchain. Transactions are the lifeblood of a blockchain. Without transactions, there would be no data to store. Here's what makes blockchain transactions unique. Transparency. Every transaction is visible to all participants in the network. This fosters trust. Irreversibility. Once a transaction is recorded and confirmed, it cannot be altered or deleted. Validation. Every transaction must be verified by the network before it's added to the blockchain. Example. Suppose Alice sends Bitcoin to Bob. This transaction includes details like the sender's address, the recipient's address, the amount, and a timestamp. The transaction is then broadcast to the network for validation. Slide 5. How transactions work. Detailed steps. Let's take a closer look at how a transaction moves through a blockchain. 1. Initiation. A user creates a transaction. For instance, transferring cryptocurrency from one wallet to another. 2. Broadcasting. This transaction is shared across the network, reaching all participants. 3. Validation. Nodes verify the transaction by checking the sender's balance and other conditions. 4. Inclusion in block. Once verified, the transaction becomes part of a block. 5. Block addition. The block is added to the blockchain, making the transaction immutable and complete. This step-by-step process eliminates intermediaries like banks, ensuring direct, secure exchanges. Slide 6. What is distributed consensus? Distributed consensus is the backbone of blockchain technology. It ensures that all participants in a blockchain network agree on the validity of transactions and the overall state of the blockchain. 1. Why is it needed? Prevents issues like double spending, where the same digital asset is spent twice. Ensures consistency across the decentralized network. 2. How does it work? Transaction broadcast. When a transaction is created, it's shared with the entire network. Validation. Nodes verify whether the transaction adheres to the rules of the blockchain. Consensus mechanism. All nodes must agree on the validity of the block through a predefined process. 3. Consensus mechanisms. Proof of work (POW) miners compete to solve mathematical problems. The winner adds the block to the chain. Proof of stake (PoS), validators are chosen based on the number of coins they hold and are willing to stake as collateral. Importance: consensus ensures that the blockchain remains secure and tamper-proof, even in the absence of a central authority. Slide 7. Achieving consensus in blockchain. Steps to achieve consensus. 1. Transaction submission. A user initiates a transaction. 2. Validation by nodes. The network checks if the transaction follows blockchain rules. 3. Block proposal. A set of valid transactions is proposed as a new block. 4. Consensus protocol. The network's participants agree on the validity of the block. 5. Block addition. Once consensus is reached, the block is added to the blockchain. This process ensures that only legitimate transactions are added, maintaining the blockchain's integrity. Slide 8. Advantages of distributed consensus. Benefits of consensus. No central authority, decisions are made collectively, ensuring fairness and decentralization. Enhanced security. Fraudulent or malicious actions are easily identified and rejected. Transparency. All transactions and decisions are visible to participants. Example: in Bitcoin, worldwide validate transactions without the need for a bank or central server. This decentralization is key to its trustworthiness. Slide 9. Challenges in blockchain technologies. While blockchain is transformative, it's not without its challenges. 1. Scalability. Most blockchains can handle only a limited number of transactions per second. Solutions like sharding and layer 2 scaling are being developed. 2. Energy use. Proof of work systems consume vast amounts of electricity. Transitioning to energy efficient models like PoS is critical. 3. Regulatory issues. Different countries have varying regulations, creating uncertainty for blockchain adoption. Addressing these challenges will be key to blockchain's widespread adoption. Slide 10. Solutions being explored. Now let's discuss the solutions being explored to tackle the challenges faced by blockchain technologies. 1. Transitioning to energy-efficient mechanisms like proof of stake (PoS). One of the major criticisms of blockchain, especially with Bitcoin, is the enormous energy consumption due to proof of work (POW). Proof of stake (PoS) offers a much greener alternative. Unlike POW, where miners solve complex puzzles to validate transactions, PoS allows participants to validate transactions based on the number of coins they hold and are willing to stake. This reduces computational work significantly, making the system more energy efficient and environmentally friendly. For example, Ethereum has already moved to PoS through its Ethereum 2.0 upgrade, which drastically reduced its energy usage. 2. Developing scalable blockchains to handle increased demand. Scalability is another pressing issue, as traditional blockchain networks struggle with high transaction volumes. Solutions to this include Layer 2 scaling, introducing secondary frameworks or protocols, like the Lightning Network for Bitcoin, which enables faster, off-chain transactions while still relying on the main blockchain for security. Sharding. This involves breaking the blockchain into smaller parts, or shards that process transactions in parallel. Sharding can significantly increase throughput, making blockchains capable of handling large-scale applications. Hybrid blockchains, combining public and private blockchain characteristics to tailor scalability while maintaining transparency and security. These efforts ensure blockchain can keep up with growing usage across industries like finance, supply chain, and beyond. By addressing the limitations with such innovative solutions, blockchain technology is positioning itself for mainstream adoption. Blockchain is a revolutionary technology with vast potential but also notable challenges. Addressing these challenges will drive its adoption across industries.